All right. Hey. What's up? What is up? How you guys been doing lately? How have you been doing? Yeah, it's great to be back. Hopefully life has been treating you well, guys and gals. Thank you for coming back, continuing watching the content. I appreciate you. Guys and gals. Thank you for learning. Thank you for growing. Turn it up. I love math. Can't help it. Call me weird. I just love it. Numbers. Yes. I love numbers. Because numbers are infinite. Okay? And there's more than 26 numbers. Let's go! Showing the love quickly to you guys and gals. Appreciate you, brothers, sisters. Parents, homeschooling your child, your children's. Here to help and support you. Again, I understand why, and I fully support you, here to help. I imagine you got a lot on your plate, so that's why I'm doing this, to help kind of take off some of the stress for you and help teach your childs or your children. Okay, again, I'm going to be sticking to topic over here. That's what we're doing, teaching mathematics and mathematics alone. That's the goal. That is the plan. Any of you students need extra additional support, I'm glad that you're here as well. And yes, of course, you are welcome. Here to help, and hopefully I could help you. If you have a certain particular area in mathematics that you would like me to do, just drop in comments below. I know I've been busy, guys and gals, doing other things. So we're back. This is good. I'm gonna do, the plan is to just grind out a bunch more videos for you guys, okay? That's the plan, okay? And I need to stick to the plan as well. All right, let's go. Time to get some work done. Flick that switch in the old brain. Molecules, let's get some math done. Oh, yeah. Oh, yes, this is gonna be good. Get the mathematics brain working and functioning again. Let's do this, guys. Quick drink of coffee. Oh, so good. You guys, brothers, sisters, I appreciate you being here and watching the content. You're super awesome. You truly are. I mean that. I know I throw a lot of love and let you guys and gals know I appreciate you. I really do, honestly. Okay? I really do. Okay, so let's do this. We're going to kind of do a little bit of review. We're going to be working with, two numbers that has a line. Okay? That's what it is. Guys, gals. It's two numbers with a line. Wow, that's all it is. Crazy. Did you know that that's just two numbers with a line? Wow, not so scary now. Not so scary. Let's go! State two ratios equivalent to 2/5. Well, that's pretty easy. You can simply just multiply it by 2 and then multiply it by 3. I'm going to try to write my best here. I'm going to try. I imagine that's what you would do. And of course, when you guys are doing this, okay, we're working on fractions. We're going to do a little bit of reducing and such. You might as well get used to doing this. Just look at a fraction in two different parts. You have a numerator part, right? And you have a denominator part. Okay, they're just two separate numbers. There's only a line separating them. Pretend it's a fence. Whatever you want to think of it. Okay? So the numerator, so this is the great thing about multiplying with fractions. It's awesome, guys. It really is. It's so easy. It's really easy. Again, I recommend you have your times table memorized. Okay? I'll just scroll this up. Get it memorized. The other thing, once you get really good at the memorization of your times table, hopefully you have it down already. But those of you that are still working on memorizing, I recommend you do it, right? You're just going to be able to solve math problems a lot quicker. That's the thing with fractions, guys. You have to find common numbers. And if you have it memorized, you're going to know what two numbers multiplied together equal a certain value. And you're going to have, for example, let's see if I can find something that might work. Like 24 is a good one. 24 is 8 times 3. It's also 6 times 4, right? And the common numbers you're looking for is like 8 and 6 and 4 and 3, right? So 4 and 3. So we know 3 kind of goes into 6. You know, those kind of things you have to think of, right? The easy ones to do are obviously the 5s. Counting by 5s. You should be able to do that. That's easy, right? 5, 10, 15, 20. Okay, guys and gals. The other thing, once you have, like, you don't have to go all the way to 12. It's up to you. If you want to challenge yourself, go all the way to 12. Okay? It won't hurt. Excuse me. But for the most part, I believe everybody kind of just goes to 10. Okay? 10 times 100. The other things that you want to memorize are the, like we're going to get into talking about squared and all that sort of stuff, okay? So, basically, for example, let's see, go here. So like 2 squared, right? Which means basically 2 times 2, okay? We'll just talk about this quickly and briefly. So you have the squareds, right? So the ones you want to memorize are the perfect squares. They're called perfect squares. We're going to talk about it now, but eventually we're going to be doing more of it. Okay, so stay tuned. Right? There we go. For example, right? And obviously we could do 4 squared as well, and we continue. So going back to here, so the squareds are basically right here. If you look at it at a diagonal, they're right there. The perfect squares, right there. 1 squared is 1, 2 squared, so starting here, right? Diagonal line. Memorize the perfect squares, okay? Just as a heads up. Okay, so once you have that done, right? Awesome sauceum. So now, going back to fractions, don't look at it as a bad word, okay? Don't let it scare you. I won't lie, I think fractions scare a lot of people. I don't know why. They fall asleep in fractions class. And then when they get into algebra and such, then they're totally bombing algebra because they failed themselves in learning fractions properly, right? It's key. So for fractions, when you're multiplying, guys, okay, I'm just going to write multiply or multiplying. I guess it doesn't matter. It's easy, guys. All you need to do is when you're multiplying is just straight multiply the numerator and straight multiply the denominator. So what we're doing here is basically we're multiplying this by 2 and this by 2. That's how easy it is doing multiplication of fractions. So to find a common one, well, we're just doubling the numerator and doubling the denominator. That's all we're doing. 5 times 2 is 10. Okay, and if we did 3, which is the same thing, cross that out. Essentially, that's what we're doing. Okay, and that's going to equal 6 over 15. Okay, so the reason they're talking about this is they're saying state two ratios equivalent. Essentially, that's what we've done. It's pretty easy. We just doubled it. So I think the reason they're kind of bringing this up is so that you can learn how to factor. Okay, another word that, you know, guys, gals, don't be afraid of. Okay, factoring is just reducing a fraction. And you got to get good at factoring, because when you get into algebra and such, you're going to be doing lots of factoring. Okay, so let's just do some basic fractions for fun. Okay, 2 over 12. Okay, now we're looking at these two numbers, right? It's just a numerator over a denominator. Two numbers separated by a line. That's all it is. Right? Nothing tragic. So we can see 2 and 12, right? So looking at it, we know, well, hey, they're even numbers. And also we know that 2 goes into 12. So I always like to say, and if you've been watching my series, you've heard me say this probably lots. You find a number, we're going to be factoring, so reducing this fraction, okay? Reduce the lowest terms would be another term that might be on your question sheet, okay? So factoring and reducing, essentially. So what you want to do is, and what I use, the term I use is finding the largest number. And what I mean by that is finding, I have this saying, taking the most meat off the bone. Now you're not going to find that number all the time. Okay, if you could take the most meat off the bone initially, that's great. Sometimes you might not find that largest number. You might have to reduce again, and that's okay too. Okay, sometimes you might end up doing it twice. It just depends how large your numbers are, right? Let's say I had a numerator or a denominator of 254, right? For example. Okay, you might not find that big magical number. You might have to reduce a couple of times. This one's small, right? We have a small numerator and a small value for a denominator, right? So we know 2 goes into both. So what we're doing essentially, guys and gals, it's just simplify it in your mind. What we're doing is we're finding two numbers that multiply together that equal 2, and we're finding the two numbers that multiply together that equal 12. But we need that common number, and the common number is 2, right? That's our common number between both of them. Okay? That's all we're looking for, that common number. Again, that's why I say I recommend get your times table done. Now, you can snipping tool this. I'm not going to show you guys. I think I've showed it enough. But you do a snipping tool. And if you're on Windows or whatever, it's basically like taking a screenshot. And then just save it, and then you can print it. Okay? So you don't... Or you could do it yourself and write it up. It's up to you. But I have it here. It's here for you if you need it. Okay. So there's our common number between both of them. We know 2 goes into both these numbers. So now all you do is ask yourself, what times 2 gives us 2? Well, that's obviously 1, right? What times 2 gives us 12? That's 6. Okay, big A's, right? Since I said it, let's drop the A's. So there you go. And now at this point, what happens is the reason we find this number here, taking most of the meat off the bone, is so that we could cancel them. We need two numbers that cancel each other. They have to be exactly the same number, right? right? And essentially what you're doing is 2 divided by 2 is equal to 1. Anything times 1 is the same number, right guys? Okay, so that's essentially what we're looking for. So what we're left with is 1/6. I might be a little rusty in writing. Okay, there we go. Okay, that's done. Boop, boop, boop. Check. So let's do a few more. We won't go too crazy, but we'll do a few here just for practice. Okay, this is easy, right? Again, like I said, have your 5s all memorized. When you're multiplying, not multiplying. Well, I guess technically we are. 5 times 1 is 5. I didn't write these because obviously it's the same number, right? I can see it right here. 5 times 2 is 10. 5 times 3 is 15, right? You can see the pattern is 5, then 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0. That's the pattern. Okay? We know, so now that we know this, we know 5 goes into 15 and we know 5 goes into 25. So 5 is the most meat off the bone number. Oh, goodness. Okay, what times 5 gives us 15? That's 3. What times 5 gives us 25? That is 5. These cancel. Boy, I am really rusty writing today. Okay, so therefore we're left with 3/5. Boom. Quick reducing, just like that. We kind of, once we get a flow going, we can go through these a lot quicker. All right, 8/12. Okay, getting a little bit more trickier, right? We know 8 doesn't go into 12, but we do know 8 and 12 are even numbers, right? So we know 2 goes into both of them, but there's a number that's going to be a little bit bigger, right? 2 is not big enough. 2 is not that most meat off the bone number, okay? We could look at our times table. We could go, okay, well, let's see. We have, what 2 numbers do we have? 8 and 12. 8 and 12. Oh, look, 4. Just like that. That easy. Okay, we know 4 goes into 8, and we know 4 goes into 3. So there we go. 4 is our number. That's our magic number. So there we go. We figured it out. Again, let's say you didn't know it, right? We're working with small numbers here. There's a pretty good chance you do know it. Let's say you use 2, right? If you use 2, then you're going to be going, what times 2 gives us 8? That's 4. What times 2 gives us 12? That's 6. Well, obviously, we're not fully reduced, right? So this is what I mean. If you don't find that most meat off the bone number, you're going to end up having to reduce again. And if you look at it, these are the 2 numbers here. So, which equal to 4, right? 2 times 2 is 4. So this is kind of reducing twice, but that's okay. Like I said, it doesn't matter. If you do, if it happens, it happens. It's not a big deal. Okay, and there we go. We're left with 2/3. Okay, guys? Boom. So I just thought I would show you that, right? There's no harm in reducing a couple of times. It's no big deal. All right, 9. Oh, 9. This is what happens when you take some time off. You get a little rusty writing. 9/27. Okay? You should have your times table memorized, but if you don't, you can look at your chart here. And we can see that 9 times 3 equals 27. Okay? So that means 9 is going to be our most meat off the bone number. We don't want to use 3. You would, if you do, right? We could. We do know 3 goes into both numbers. Again, you're just going to be reducing another time, right? Blah, blah, blah. What times 3 gives us 27? A big number. 9. Okay, 9. So go equals, these cancel. Then we're left with 3/9. But we're not done yet. We can still reduce that another time, which is 3. So again, that's our magic number, 3. Again, I can show you the work. These two numbers here are what gives you that most meat off the bone number right there. Okay, we should have picked 9 right from the get-go. Okay, but that's okay. We'll do it a couple of times. And I'm just showing the work here for you. Okay, what goes into 3? That's 1. And that's 3. We're left with 1/3. Okay, boom. Now I'm showing you a little bit of extra work, guys. Okay, don't let it scare you. It's just, I'm just showing you, if you don't find that largest factorable number in the beginning, it's okay. Alright? Just showing you that you can still reduce, you can still keep going. No harm, no foul. Alright? Okay, so I'll give you, let's do this one here quickly. These ones, I don't even really waste a lot of time doing. When you have zeros, here's my tip, and I kind of, kick myself a little bit. Don't reduce when you're cross multiplying, okay? You can only reduce when you have in fraction form, okay? I'm solidifying that in my memory banks so I don't make that mistake again. So, only in fraction form can you reduce, all right? Key information. So, whenever I see numbers with zeros, it doesn't matter if it's 300 or if it's 700 or if it's 3,000 or if it's 7,000. It doesn't matter, guys. You could really just cancel the exact same amount of zeros and you're still left with 3/7. Okay? I think that's the simplest way, but maybe your instructor might want you to show the work. Essentially, 10 is going to be the number, your most meat off the bone number. With that said, we're basically pulling 10 off of both of these numbers, so you're left with 3/7. I just cancel the zeros without even thinking about it. Okay, but again, you might have to show your work. If you have to show your work, then you can just go like this, go 10, then 3, 10 again. Again, that's the number we need. So we need that two numbers to cancel each other, right? Showing you the work. There it is. Okay. Do do we need to do any more? I don't know. I'll give you some other ones if you want to practice. Okay, guys? And the best way to figure out if you have the right, like if you reduced it properly, you can just divide it. Let's say it's, I'm just guessing here, 4/5, okay? Just guessing. Actually, it looks like it's correct. If 4 divided by 5 is 0.8 or 0.9? I think it's 0.8 divided by 5. Yeah, 0.8. So if you just divide the two numbers, I get 0.8 or 0.8, whatever you want to, it's all the same. That's one way of checking. Just check your calculator. If your fraction, you could go 12 divided by 30, right? 12 divided by 30. Ah, there we go. So I have the incorrect answer. Okay? 12 divided by 30 is 0.4. 4 divided by 5 is 0.8. So they're not the same. So I guessed, and I guessed incorrectly. 6 goes into, we'll just do this one quickly now that I know 6 goes into both of them. 6 is that number. We'll just do this one quickly. Times 2. Ah, there we go. Now I'm seeing it. Yeah, I just have my numerator doubled. There we go. Okay, our actual answer is 2/5. Okay, so just as an example, that's how you can check. So I had 4/5. Okay. And again, I wasn't really actually doing the math in my head. I just kind of guessed numbers and just went with it. And the main reason was to show you, if you're not sure if you have the right answer, just divide it. Get a decimal value on your calculator. It's one way to check. And the other reason I brought that up is if you want to, did we do all of them? I think we just did all of them. I was going to give you some other problems, but I think we just did them all. Again, I don't know. I could give you some other ones here. Let's see. I don't know. 4. We'll just give you some. I'll just give you some random ones, okay? Let's see. What else could we do? 2 over, I don't know, 14. And then let's go 10 over 35. And 8 over 16. And 9 over 36. And let's see, 12 over, kind of just guessing here.
The CIBC Newcomer Bank.
Okay, I gotta block a commercial. I'm just going 44. Okay, let me deal with this commercial. Skip. Carrying on. Okay, there we go. Just for funsies. There's some random fractions for you. Okay, so pause the video, do whatever you need to do, practice them. Again, just divide the numerator by the denominator. Numerator first, divided by denominator, and compare your decimal values. And then you'll know if you have the right answer or not, okay? All right, let's set our mind to, we're going back to ratio proportion. Okay, ratio proportion, I love it because you can compare, let's say you have a known fraction, you want to compare it to some other value of some sort. you're unable to do, I don't know, some physical measuring or whatever the reason, and you want to compare it and figure out a distance or something, for example. All right, ratio proportion is fun. Now the ratio proportion, you kind of setting up is kind of key, but I have some problems here that are already kind of set up for us, so we're just going to work them out. And I think we've gone over a few of these already, but have I gone over these already? I don't know, maybe I did. It's been a minute since I did videos. So I almost should have watched my videos first. That's okay. I remember, the reason I'm thinking that is because I remember kind of doing this, and I'm showing you guys here that you could just reduce this automatically. And that's why I say, here we're doing cross multiply situation, and this is where I messed up before. Thinking that I could kind of get away and kind of shortcut the system, and it kind of bit me in the rear end. But that's okay. I don't mind a little bit of making mistakes, because that's how you learn to get better, right guys? Open mind. You can't reduce here. You can only reduce in fraction form. With that said, I actually can save myself some reducing time, because if you multiply ahead of time, then you're just going to end up with some really large numbers, right? 10 times 30 is obviously 300. Okay, so now you have some really large numbers to reduce. Okay, you can save yourself some time by reducing ahead of time. Again, you guys should know we reduced this one already. Okay, I'll just show it to you right here. Okay, we're going to end up with 3/5. Okay, so now all I need to do is cross multiply. Okay, I always like the X on the left side. Okay, so it's going to be 5 times X or 5X. I haven't checked the stream to see if you guys... Hi! Hello Thermal Hatra. Just checking out the stream now. Appreciate you being here. Thank you for stopping by. Hello. It's great to have you here watching. You're awesome, awesome! Let's go! This is for you. That's awesome. I love it. People that want to learn. Throwing out shout outs go to Thermal Hotra for stopping by and saying hello. Appreciate you, and it's great to have you here. I do want to check the stream, make sure that I didn't check it. I got to do mod stuff, guys. Make sure you can hear me. Stopping by, saying hello. Testing. Oh, goodness gracious. Testing. Okay, we're good. It's really weird thing. Like I have the music that I'm playing down low, and I brought up the stream and I was sliding the volume slider, and it's really weird. The cursor like glues itself to the circle that's on the volume slider on YouTube, and it literally is stuck to it, and I'm sitting here trying to listen for me talking, and I had it on mute. It's like, are you kidding me? Why is that even a thing? Why is that even a thing, YouTube? Another thing that bugs me about YouTube is you could right click a music video and you could select loop. Okay? So I like to kind of just walk away from my PC, go do things, make coffee or whatever, go make a sandwich. And so that my computer doesn't fall asleep, I'll play some music, right? I'll have a YouTube video, music video up or something, whatever I'm listening to, like music like this, for example. And I'll just put it on loop, okay? And I don't know if it's a commercial thing or what it is, but YouTube, I don't need a little pop-up for you to ask me if I'm still watching. Okay? It's a little bit kind of silly thinking. Why would I have it on loop? Obviously, if I put it on loop, I just want you to play. I don't need your little pop-up message pausing my video, which equals my computer going into sleep mode because you asked me a stupid question, which I didn't even need to be asked. If I put something on loop, there's a reason for it. I don't need to be asked if I'm watching. Okay? Thank you, YouTube. Fix that, please. Sorry to go on a little bit of a tangent, guys. I don't know how to tell YouTube. Maybe I should do a separate video on that. Like, it just seems really silly-minded. If I put something on loop, that means I want it to play. I don't need to be asked. Obviously, I'm away from my computer. I don't need to be asked if I'm still listening. I'm not even in front of my computer. Goodness gracious. The humanity. All right, let's focus back to mathematics. We're good on the stream. I feel like I've done these already, guys, but we'll finish this up. So 5x equals... So I'm left with 10 times 3. Okay. This is the point where I call this inline. This is kind of how I teach my kid. We're taking it from, just for memory's sake, so that he remembers the steps. I say cross multiply, then inline, or whatever, however you want to look at it. Like, it's everything's left side equals left hand side equals right hand side. Essentially, that's inline or linear. Okay, everything's kind of in line, right? In a row. That's what I mean, guys. Okay, that's kind of step 1. Step 2, put everything in line. And then step 3 is isolate x. We want to isolate x. Isolate. My mouse writing skills are brutal, guys. I wish I had a tablet. This would be better, but that's okay. Still pushing, still grinding, doing it for you guys and gals. Okay, isolate x. What I mean by that is we want x to be 1. Okay? Essentially speaking, this has a value of 1. Okay? Guys, we call this imaginary 1. Like, it is x. It still has a value, and that value is 1. Okay? Just to be clear. So, what we want is we want x to be 1. We don't want x to be 5. We want x to be 1. Okay, so that's what I mean by isolate x. So, to do that, here's the other thing I teach my kid. Math is kind of like a balancing game. Okay? Now, I'm sure you've played in a park as a kid, and you've played on a teeter-totter. Okay? This is kind of my analogy or analysis. Right here is the equal sign. Okay? If you are adding on one side, and whenever you move a value to the other side of an equal sign, you're changing the sign. Okay, you're changing the sign. So for plus, when you go from the left side of the equal sign to the right side, you change the sign. Okay, remember that. Just think of teeter-totter effect. You can even draw this little diagram, sketch it up just to help you remember. However you want to do it to memorize, right? So it's no different with multiplying. If you're taking a value from one side of the x, well, what do you do to the other side? It becomes a division. Okay, so showing you here, without doing all the extra work, again, this is all numerator stuff here. Okay, that's a numerator, guys. All this is technically still 3 times 10 over 1. We just don't write it. Okay, so check it out. Whoops. 3 times 10. I'm isolating x over 5. So all I did was take the the 5. I don't know hopefully I'm not too sleepy, guys. I got to catch my little mistakes here. All we're doing is moving the 5 from being a multiply to a divide. Now I can show you the work, the long work. A lot of instructors might show it this way. Divide both sides by 5. It's the same thing, guys and gals. Same result. Okay? What I'm doing is I'm teaching you kind of the teeter-totter analogy, just to simplify things so you don't have all this extra mess. Okay? That's just extra writing and an extra mess. So all I have to do, if you understand how the math works, and if you understand the logic of what you're doing, I just showed you the work. If you understand that, you don't need to do all that extra mess. Look how much cleaner that is. Okay, there we go. Isolate x. Right there. Right here. So now it's just a matter of working out the problem here. So we're going to do the BEDMAS, right? It's still kind of like BEDMAS. So we have to finish up the numerator. We need a single whole number. 3 times 10, which is 30. That's a single whole number, right, guys and gals? There we go. Okay, now we've got the numerator to a single whole number, and we have the denominator as a single whole number. Therefore, equals, we can reduce now. Knowing your times table, if you look at 30, 5 times 6 is 30. Okay, therefore x is going to equal, essentially, we could actually do the long work. If you wanted to see the long work, I could show it to you. We could factor 5 times 6 is 30. What goes in the 5? We're factoring the 5 out of that 5. The 5's cancel. Showing you the long work. We get 6 over 1. Again, I'm showing you the long work, guys and gals, right? So that I'm not shortcutting. You can see how it all works, right? If you understand all the little steps of what happens in between, you can skip all this. This is all redundant, right? It's kind of my point. You don't need to do all that extra work if you understand what happens in between from here to here. Okay? I gotta deal with another commercial. Hang on here, guys. Again, if YouTube shared my videos more, I'd probably share their commercials. All right, hold on, guys. we doing for time here? Okay, not bad. We're getting close, though. I'm going to clean this up. So that's kind of the steps. Okay, guys? Now, if I go back here just quickly, this part here, right here, if you wanted to screenshot that as well, it's called snipping tool. You know, there you go. I just created a little snipping tool of that. If you need it. Okay? Save it on your laptop or your PC, whatever you're working on. And then you can just print it off. Alright? Again, same thing, right? That's kind of what math is. Math is a balancing game. What you do to one side, you got to do the opposite to the other side. Really, that's what it is. Okay, so I feel like I've done these ones already. But if you want the extra practice, here's a couple more. Okay. Do I have an answer for that one? Let me just see. Number 4. Do I have answers for that? Doesn't look like it. I'd have to do all the work. Again, you could reduce this, guys. Right? You can reduce ahead of time if you want to save some time. Same thing here. Here's another one. I recommend you reduce right from the beginning. Okay? Figure out what the common number is between these two numbers. That's supposed to be an N. Looks like an H. Okay, and 8. Now, you could do your cross multiply ahead of time. You can, but again, save yourself the extra work. Just reduce in the beginning. That's reducible. You can factor. All right, again, it has to be in fraction form in order to do that. Okay? One more here I'll give you. Just for practice. Okay? There we go. I just want to kind of keep moving forward here. I have some other ones, but I feel like I kind of went over these already, but we'll go through this quickly. I feel like I kind of already did this. So here's another one. Over 5 if you want some more practice. It's fun. Okay? Okay, just to give you a heads up, you can't reduce here. Okay, there's no reducing. Just do the straight multiplication, straight cross multiply. Okay? Again, like I said, you can only reduce if it's in fraction form. Okay? Obviously, you can't reduce from x. Okay? Has to be in a fraction. I did say one more, but I found some other ones. I figured I'd share these with you as well. 15 over n. There we go. And then here's another big one. I don't know if you want to do this one or not, but this one's large. You can't even reduce here right now. It's going to be one of those where you can only reduce at the end. Okay? There we go. All right, let's keep moving forward. Yeah, I think I've already kind of gone over these. I do apologize, guys. Yeah, we've kind of already gone over these, but I've given you some extra ones just to work. For me, it's kind of a bit of a refresher. I might even have some answers for that. 5A. See if I can bring it all back. Okay, I'm just looking. It may or may not be the right answer, but this one here, n is equal to 28 is what I'm given. That's for this one. Whoops. And for this one, yeah, I think I already gave you guys this one, I do recall. 7.5 or 7.5. Okay? Alright, I apologize, I kind of went over that again. I should have watched the videos just to kind of get an idea where I was. That's okay. I remember doing this now. Let's quickly, we're going to go into what is rate, right? You might hear like, what does rate mean? What is rate? What is rate in mathematics? And then this is what we're going to go on to in the next video, okay? What is rate? Rate is a special type of ratio that compares two quantities with different units of measurement. Okay, so for example, you'll see something like, I don't know, rates and unit rates. So a lot of you guys are already familiar with stuff like this, but you'll see something like miles, right? And then we usually go per. That's what the per part means. Per 3 hours. You might be working out a problem of some sort. This is something you would set up yourself. Whatever the word problem, it'll say something blah 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 about 60 miles, and then you do that distance in 3 hours, right? And then essentially you want to kind of figure it out in an hourly. Obviously that would be, we know we could reduce this, right? So you would end up with 20 miles. Like how fast, what was your speed or your rate of speed, right? Per hour. So it would be 1 hour, right? As an example, that's rate. Definition of rate and then unit rate. Let's see if I can find some kind of definition here for you. Rate definition: when two quantities of different units are compared and expressed as a ratio, right? So essentially the ratio would be, you'll see it written like this, miles per hour, or you could write it like this. You'll see it written something like this, right? For example, in math, a rate is a ratio that compares two different quantities which have different units, right? Obviously, yeah, you can see that. Two different quantities, two different units. Okay, these are the units. What is the best definition of rate? A fixed ratio between two things. A quantity, amount, or degree of something measured per unit of something else, like heart rate, metabolic rate, pulse rate, obviously speed and velocity. Velocity is a rate. Okay. Let's clean this up. This is kind of what we're getting into next video. So I'll go over these ones real quick. Since I kind of, went over something, I guess we could look at the prior stuff as kind of a review, if you will. Let's see. Heart rate, obviously, is measured by counting the numbers of beats per minute. This commercial's unbelievable. Beats per minute, right? Get skipped. I really don't like commercials because it really throws me off topic here, off focus. Okay, here we go. Is ratio or rate, right? Here we go. Is it a ratio? Or is it a rate? Okay. You have one teacher in a class with 40 students. Is that a ratio or a rate? Okay, you just got to think about it logically. So I think, one teacher, we have one teacher in a class with 40 students. One teacher per 40 students. That looks like a ratio to me. Okay, because you don't really say teachers per students, right? That's not a rate. So you could think of it that way. That doesn't make sense. You need something that says like miles per hour, for example. Okay, so that would be a ratio. 100 kilometers in an hour, in 1 hour. There you go. I know we're talking about a metric system, but there we go. So, boop, bop, bop. So that's a rate. Pretty easy, right? 3 granola bars for 200, not 200. 3 granola bars. So I don't know, I'm just gonna say bars. For $2. And 40 cents. Okay, that's not a rate. So we could figure it out in a ratio. I think so, right? So what you're going to want to do, this is the unit price concept. Unit price. If you want to I kind of did this stuff if you want to check out. Hopefully you've watched it. I've already kind of done this. Not the geometry. It's either 3 or 4. Unit 3 or Unit 4. Measures of area. Probably Unit 3. Okay. I go over unit price a lot, I think. And I think I give a lot of good examples. Okay, so essentially what it means is you're going to want to figure out how much does 1 bar cost, right? Right? What is the cost? Right? So it's just a matter of doing a little bit of math. Again, if you don't let decimals scare you, if you look at this here, guys, you have the number 3 and you have the number 240. Okay? If we just get rid of the 0, we know that 3 goes into 24. We could do this without even, just ignore the decimal, guys. Decimal is just a position, right? I moved the decimal to behind here. So we know that what times 3 gives us 24, right? 24, that is 8. So I'm going to write 8. Okay, our decimal is here though. Okay, how do you figure out where the decimal goes? Okay, because 80 times 3 is 240, right? I put the 0 there. Okay, I just ignore it. I crossed it out, but it still exists. It just wanted you guys kind of just ignore it. Okay, the 240 is still there. 3 times 80 is 240. Where does the decimal go? Well, it's 2 jumps, right? 1, 2 jumps. 1, 2 jumps. Okay, there we go. That's where the decimal is. So essentially 1 bar is 80 cents. Okay? You gotta look at math as numbers have patterns and sequences, especially when you're working with decimals, right? If you just ignore the decimal, you can figure out the number in your head, because again, you see the number $2.240, but if you ignore the decimal, you can see the 24, right? You can figure out where the decimal goes at the end. That's just kind of a quick tip for you guys and gals. Okay, we'll do one more. You have 20 computers. Okay, you have 20 computers. All right, for 40 students. Whoopsies. Now, obviously, you have more students than computers, so it looks like people are going to be sharing. That's going to be fun, huh? Again, we can reduce here, right? It's going to end up being, just cancel the zeros. I would have had 2 over 4. We could still reduce, which is 1/2, right? So that means we're going to have 1 computer per 2 students. Okay? So essentially, we're going to be sharing, right? All right, we'll do a few more of those, and then we're going to get into just kind of figuring out, there's short sentences, but we can figure out, create our own ratios and rates. Yeah, so 20 computers for students. I'm going to say ratio, right? We did a ratio. Again, we would have computers. There's no such thing really as, we don't say, it's not really a rate. Thinking and writing. Computers. Computers. Learn how to write. We don't go computers per students. I guess it ends up being a ratio, right? It's not a rate. Okay, finish writing. Less talking, more writing. Okay, guys, gals, appreciate you being here, watching. Quick shout outs to Blues Boss Gaming, 20 miles per hour. Let's go. That's right. You guys, I'm ending the stream, but I'm planning on doing another one. If you have time and you want to drop by anytime. It's great to have you in chat, commenting. I have the YouTube music playing, so I I kind of have that covering my OBS studio. I will check on it once in a while to see if anybody's in chat. It's great to have you here. Quick shout outs, Thermal Hotra and Bluesy Boss Gaming for stopping by. Bluesy Boss Gaming, let's go. If you're into learning coding and maybe Unity and making your own games, you have found the right channel. I do even math over here. If you want to learn, just let me know. I'll help you out and teach you. I'm good at coding in C# and using Unity as well. That is it. Appreciate you guys watching. I will see you guys and gals in the next video. Take care for now. It's Johnny, Whiskey Tango Sharp. Much love, and I'll see you guys next video. For now, take care. Whoever you are, wherever you are, have an awesome rest of your day. Yeah, that's enough. That's it. Yes. Who's? I had to stop myself. Check you guys later. Thanks for being here. Peace out.